Swayam Prabha. Digital India. Educated India.
Hi everyone, welcome back again to online NPTEL course on structure, form and architecture, the synergy. Today we are at lecture number 33 and we will be discussing on different structural form and architecture in flat phone area. So, before starting this lecture, just let us quickly recap the things we have discussed in last two discussions, that is the structure for the windy area and earthquake prone area. So, how we can make our building safe during that hazard, and different structural system, different building shape considerations are found to be instrumental, and like that we will be getting some insight in this discussion today, where we will see the building form and different technology by which we can make our building little bit resilient to the flood vulnerability. So, let us get started. So, what is a flood? So, we all know, and recently in this year we have seen, if you just search by the flood in 2019, so we will get many such pictures. You just go to Google image and you will get the image of the flood scenario, and I have picked up this one. So, in this slide what we can get few definitions or just concept of that. So, flood is an overflow of water that submerges the land that is usually dry. So, flood is a condition where it is a waterlogged situation and due to the overflow of the water, it may be due to the overflow of the river, mostly that the case. Sometimes it may be some unprecedented rain which will just submerge the city if the drainage system is poor, and then that may be very much catastrophic. Unexpected and sudden storm can also like create this kind of situation, and recently if you just search about some flood scenario in recent time like Patna in India. So, it is basically some rain that has happened after a long year, and the whole city that affected badly. The primary effects of flooding include the loss of life. It is a direct one where is a heavy flow that blown away the people, that may, or it may be something where it is the after effects, like during the flood there will be more problem with the health, and then that may lead to the life loss. That also damage the buildings, different property, different infrastructure. So, we will be focusing on the building in this lecture, but yes, this flood scenario will essentially be a threat to reduce the economy, and also it provokes the secondary hazards such as winds. If you see in this slide, the wind storms, then lightning, slope instability, ground settlement due to that liquefaction that we have just discussed in in the previous lecture of the earthquake. And here you can see the pictures where it is very badly waterlogged situation, and then you can imagine that problem one may face where it is really area is flooded. Coming to the flood problem and the fundamentals, the flood load that is there. So, whenever there is a waterlogged situation, so water will try to pass. So, it will have a direction, it will have a flow with a slope, natural slope, and on its way if it gets some obstruction, definitely that will create some thrust here, and at the opposite side it will have a negative pressure or the suction like the wind. So, again here if you can see the direction of the flow, and then the opposite side it will have the problem. So, lateral forces resulting from static and dynamic water pressure in flat situation is very dangerous and it may be really catastrophic. And here you can see two such images where you can see the heavy flow of water, how it really damaged the building and it is a total collapse. And you can get such example many numbers if you just search. So, this is really very risky wherever the situation is like that. So, first of all, with this water, the ground, the soil will very much loose, and then that will really suddenly lose the bearing capacity, and that may result to the collapse of the building. And the reason for damage in flood, if you see that in this slide, so it will depend on the flood depth, like what is the level of the flood. So, if it is the surface level and the flood is for say 4 feet or maybe the 6 feet, whatever the depth, so that will have. So, if it is very low, so again the again it will depend on the slope that will decide the movement, that will also decide the velocity, and then the depth, and based on that whatever the damage of the building that may occur. So, whenever it is low, considerably low, maybe half feet or 1 feet, so normally the buildings they are having plinth. So, water will not really go inside to the room, and we can just then also deal with that situation. But if it is beyond that 4 feet 5 feet depth is basically very much vulnerable. So, if the plinth is of not that height, at that height, so that will damage the building very badly. Then the flood duration. So, if we have very proper drainage system or some mechanism to ease off the situation, so then the risk will be less. But if there is a very bad infrastructure or there is nothing to do, the duration is so long, so for last 7 days or something the situation exists, then the damage and loss will be more. Then uplift due to the soil saturation, that is also related to the your liquefaction. So, whenever a flood state for a longer duration, so this kind of scenario will happen. Then horizontal force created by the flood waves or current. So, this is basically what you can see in these two images, and whatever I have described here, the direct thrust and the negative suction at the back where the flow is being obstructed by a building. The flood water can submerge building and cause various degrees of damage, from straining the wall to the structural collapse. So, gradually it will create the strain in the building, it will deform the building, and then that will collapse, and it will also depend on the depth of the flood and the duration of the flood, and also the type of the building. If your building is kacha type, normally if we consider the case of the rural area, so normally they are making the brick, maybe making of made of earth, or maybe sometimes it is like some kind of admixture as cement to that. So, they will be more vulnerable because they will not have that resistance to deal with that flow and the thrust provided by the water. But compared to that, if you have some structure of RCC or maybe some very strong material, that can again resist something, provided that the foundation is well anchored, and then the duration is not that much. Even if the duration is too much, the subsoil will get liquefied, and then even the strong building will collapse and they just uprooted from that. So, here are some of the pictures which actually depicts the scenario where the situation is really not welcoming. The buildings, whether it is new or old, so that badly affected with the flow. And here is the situation during the flood, how you can see that everywhere is the water, and you can see how people they are threatened. And if this will continue again, the heavy rainfall, and so this building may also collapse like this video. Here is another image where you can see that the situation during the flood, it is from some different country. Here also you can see that how the whole area is now submerged. and this is something from Patna. So in recent flood, so you can see that construction, like some of the buildings already submerged, so you can only see the roof, and half of them are already damaged. So again, this is really not welcoming to the society. And this is another example where you can see the buildings how it's submerged. Now, effect of flood on building damage, it may damage the foundation, it may damage the wall and the roof, or everything together. So it depends on the material that we use, like for the foundation, for the rural area especially where the loss is more. So you have to rebuild your structure once the flood scenario has gone. So you have to rebuild the structure. So this is something really serious. But even sometimes if you make it with the timber or light material and not anchored properly, so the whole building can be blown away with the flow, and there are many instances of that. So it may be a brick, or maybe brick and concrete kind of foundation which may sustain bit, and if it is like the RCC or maybe the steel, so that will sustain depending on the depth, whether you go for isolated foundation or pile foundation. So depending on the foundation also it will depend. Now the wall where the at the ground, above the ground, the water will first stuck with that particular portion. So if it is of earthen material, that will have become porous if the duration is quite low. So that will be softened, and then there will be collapse. Then it may be of the cast iron sheet, especially for the low cost construction this being used, which will also not be strong enough to protect it. Like the brick, even depending on the structural age of that construction machinery work, so it will depend whether it is glass or RCC. So depending on that, the collapse and the degree of the damage will depend. So that's true with the roof. If it is a thatched roof and all, so with the heavy rain and all, so it will not really sustain. Whereas you have a concrete roof, flat roof, that may sustain. And sometimes it is also advisable, like whenever your building is to be built in flat prone area, so better to go for a flat roof structure, so that at least during that situation like people can just accumulate there at the rooftop, and that we have seen in one of the images. And whatever we have discussed there, so in this, like the design and construction of flat prone building structure, so we can work on the elevation of the structure. So this elevation is different from the elevation that normally used in architectural design, that the front view or something. This elevation is related to the height of the building with corresponding to the surface or the flood level. Then the dry flood proofing is one of the technique. We will be discussing that. Wet flood proofing may be one of the solution to reduce the risk during the flood. It may be the flood walls that being constructed to protect it to certain level. It may be the levee that we can create to control it. And then another is the anchorage and connection. So whenever you make any light structure, that should be anchored very perfectly with the foundation. And if you make your structure with different materials, so those connections joint should be proper. So beam should be well connected with the columns, and columns are well connected with the footings, and then so as for the roof or the ceiling or the floor. So that is there. So we will go one by one to just see what exactly it means, the dry flood proofing or the wet flood proofing, and we will try to understand. Coming to the elevation of the structure in this slide, so elevation for the lowest inhabitable area should be above the base flood elevation. So this is very important. So in this case, if you see that this is the base flood elevation level, so you can easily see in the case of the first one, so your building is emerged, so this is not advisable. And in this case you have plinth up to this is just at the base flood elevation. So this is somehow better, but when this level will go up, because with continuous rain and also this may definitely subject to go up. So, you should make your structure like quite above from this particular BFE. So, then you can make your structure like risk free to some extent during the flood. But definitely when you make your building little bit raised from the surface, maybe this is the the land surface. So, when you make this plinth of that height, definitely cost will be additional. You can easily make your plinth low, but if we consider the risk associated with this flooding situation, it may occur occasionally, means unpredictable, then it is different. But if you know that your building is your site where you will make your building is really having this threat of the waterlogging or the flooding situation, so definitely spending little bit initially will really save a lot in long run. So, you can really sustain during this situation. So, elevation of the structure is one of the important measurement by which you can reduce the risk during the flood. This is the example what just I have shown. This is a picture where you can see that the situation is waterlogged, but as because you have a raised platform and you can see that this particular height where this is raised. So, maybe this bottom portion you may use for some basement and you can see that ventilation. So, the access to your room is quite above to the base flood elevation. So, this is considered to be safe or having better performance during the flood. This is again the same case where you can see with this particular stair you have the level quite high, and this could help during the a flood maybe of the 4 feet depth or something. So, this heavy depth flood situation also these buildings can be survived. Coming to the dry flood proofing, so here is basically to protect the house against flood without allowing water to penetrate. So, we make our building, okay, we do not allow water to pass on. So, we make our building so strong that it will resist that particular flow. So, that is something where you can use some additional flood panel. So, this flood panel will protect that direct thrust of the flood water towards that building, and even here you can see like the doors and other thing is being protected with a movable shield which will be removed when the flood level reduced, and then the risk will be reduced or that will be lowered down. So, in this case we will not allow any water to penetrate. So, this is the dry flood proofing technique that we can adopt. This is another picture of that where this being protected. So, this is removable and this is the entry. So, this is already being made with some plinth made of some stone which will not really allow to penetrate the water. We have to remember, if you go for the masonry work or the brick work, it will be porous. So, that may also that may also get affected, but whenever you go for this plinth of stone or RCC, that will be. But wherever there is entrance, you cannot have this plinth, and then you can go for with this flood panel. So, this is the way we can go with the dry flood proofing. Now, coming to the wet flood proofing. So, in this case we will just take that, okay, there is a flow of water, let water flow will not disturb, and there will be, and that if that flow is not disturbed, that will not also disturb us. So, the concept is to allow water to pass on. So, that is why it is called wet proofing. So, here what you need to do, you do not need to make any plinth as such, you have to make your structure still. So, stilted structure to be made where this is having a good height considered to the base flood elevation, and then allow water to pass on. So, in this case this being made, and here is whenever there is no flood situation we may use as a basement where the basement and this kind of structure being made. And during the flood situation, as because the flood is not very uncertain like earthquake, so there will be forecast and there will be a scenario that okay, this water level is getting high, so that is giving an alarm to us. And then if something is very much of that utility in the basement kept, so we can shift it in upper portion, so that's it's what is there. So in this case we allow water to pass on. So here is the example where you can see that all the structures that being made at quite not at the surface, it will have a height, and we have only this particular columns and some bracing to just hold the load. And then during the flood, normally for the area in the coastal area or near the bank of the river, this kind of structure will help. So during the flood levels, water can pass on, and then there will be no such damage. So this can be one of the way out during this flood scenario. So wet flood proofing is one of the option. So this is another same example under this wet flood proofing, where you can see that in absence of the flood scenario, that may be used as a parking and all. And then these are the panels that is removable during the flood. We can remove it so that water can easily pass. So whatever the direction, there will be a predominant direction depending on the slope. So everything is well calculated that if there is a raise, so where from the water will go and in which direction, accordingly this can be oriented. So this could be helpful. So this wet flood proofing technique may be adopted, and that will reduce the risks during the flood. Coming to the flood walls, it is not the building, so will not allow water to enter to my campus, enter to my own premises. So then we create some RCC wall or some wall of the some metal which will not allow water, and they will have a considerable height. And then whatever the water locked in my premises, so that will have some pumping system which will plus out the water outside. So by which if we create the boundary well sealed during the flood, so that may also sustain. So a boundary waterproof or flood proof boundary wall, or that is also referred as the flood walls, will be helpful. So here you can see that how this can be. So this area is basically having this water, and this is very dry. So with the help of this panel and then the continuous barrier, so this will act as a flood wall, and that will protect. So that similar kind of system we can adopt. It is maybe a temporary structure, or we can make the RCC wall, so that will reduce the risk during the flood. Now coming to the levee, so here it is not basically the wall form. This is a dues that we can make a bump. We can create a natural slope with some kind of soil, so that will not allow water to come inside. And whereas again, like the previous example, so whatever the water accumulate within my premises, we can just drain out that water with a pump to this site, so that by this also we can make our structure safe, not the wall, just a mount. So here you can see that this is a railway track, and there is some water body, and this is being protected. So if there is increase in water during the flood, so this will initially help to not overflow this water to this site. So this is the profile is being maintained like this. So where water rise, so this being calculated what would be the maximum flood level for rainy scenario, and based on that this levee can be created, so that the other side will get the protection. So this can be used for the road, it can be used for city boundary, like a initial, like similar to a dam, but that can also be used for like where we don't prefer to have a boundary wall for my building, we can use this. Along with that, sometimes we also use that flood barrier. So, it is nothing but a tube. So, this tube is filled with water and that will have weight. So, that will have enough strength to just resist the flow of the water, and that can really help. So, this is a hollow balloon like structure. We either can put air or else we can put some water already. So, that will act as a barrier during the flood. So, we may have the flood wall as a system, we can use the levee, we can also have this temporary tube that may act as a barrier. Now, coming to this anchorage and the connection. So, here what we need to remember, that design should be like that, which to be designed and executed to withstand the influence of vertical load, uplift force and lateral loads. So, vertical loads definitely that will happen whenever like there is some force acting on it, and there will be some saturation, soil saturation scenario. So, there will be some kind of change in the subsoil. So, we have to make it very strong. So, they should not be something like where the building will tilts and then the foundation that will come out. So, that should be anchored properly. Beam shall be connected to the piles, columns, piers, to the foundation accurately, so that they will act very strongly against that particular load whenever it is applicable during the flood scenario. Then sufficient anchorage need to be installed for the storage tank and other sealed conduit pipes and other thing, because with the motion, if this anchorage is not there, so that will be blown away. If you have a water tank just in your premises or somewhere like it is at the top of your rooftop, but it is just simply placed. So, wherever there is a heavy thrust or so heavy wind, thunderstorm, that may also create the problem. If it is like a conduit pipe and all, so that is also exposed, so that may damage. So, if there is any leakage, so that may also get affected during the flow of water and in flooded situation, and then definitely that will create multiple problem for the drinking water or the daily services, and that create the environment really unhealthy. So, we should avoid that scenario with a proper anchorage. Now, coming to the summary, here we have seen that again the flood is something where it is the overflow of the water that may cause due to the overflow of the river, or it may be like due to the unprecedented rain in a closed form where the drainage system is not adequate. So, all of a sudden heavy rain and storm will make the scenario, and then the it will affect the foundation, it will affect your wall, it may really affect the total building as a whole. And then what we need to do, basically we have to just make us ready, we have to prepare ourselves to reduce the risk of that. And there are different ways that we have seen in this discussion by which we can reduce the risk. One is the raise the elevation is the technique. Okay, so where this elevation should be your base flood elevation, and like increasing the plinth, this is one. Then we have also seen the dry flood proofing technique, where like we will not allow water to penetrate, and for that whatever the openings and other elements are there. So, we have to protect with a movable flood panel. So, that will help. So, whenever there is no risk or risk is now not at that level, so then we can remove it. Then we can go for a wet flood proofing. So, in wet flood proofing it is contrast to the dry proofing. So, we will allow water, and that is why we take our building at different heights. So, water can easily pass through, and whenever there is no water, this can be used as a basement, this can be used as your parking, etc. So, this is your wet flood proofing, and this is your dry flood proofing. Now, apart from this, what we can do extra, that is your flood wall, and also we can go with the levee. So, we can create the flood wall at the boundary, so that water level that will not go out, and whatever the water accumulated inside, that will be pumped out to the external. And in the levee it is the mound again that will actually help for the city level or the individual level. And the sixth one is the anchorage, which will be taken care of with the structure, and also the non-structural elements like the pipe and other things, so that the damage will be less, so that we can do it. Now, considering the form, there is no such basic form that being described here, but the thing is all related to whether we will allow water to flow, which will help to get less impact on the surface. And if you do not have this option to lift it up, or you have other concerns, then probably you have to go with the dry flood proofing, where you have to provide the proper shield during this flood situation, by which we can reduce it. And definitely with the previous discussion as well, the wind, then seismic activity, this flood, if an area is of multi disaster prone area, so definitely we should be very much careful. Like maybe we cannot stop the phenomena to get offered if it is a natural in nature, not man made, but at least we can make our building taking those kind of concept and following different guidelines which are available, so that we can reduce the risk during that hazard. So, with that I conclude this thing. For study, you can go through some of the flood resistant design and construction guideline from American Society of Civil Engineers publications. You will get such more information. Even you can search some of the reports that being developed like in the context of Indian cities, so that it will help you. And even the risk what we have discussed today is in very general, but this phenomena like this flood and the risk associated in the rural area is quite high, as because the building materials they use, the technology they used, they will fail to resist during that. So, with that we will have a discussion, we will discuss in one lecture of cost effective your structure and architecture. So, where we will discuss again how to make the structure with the cost effectiveness, and even without compromising all these threats. So, basically how to make your building earthquake resistance or flood resistance with the low cost technology, even for the rural housing, that we will be discussing in the next lecture. So, that is the lecture that is upcoming, which is lecture number 34, cost effective structure and architecture. So, this will be very much helpful to know not only the high rise skyscraper and different beautiful structure, now also this can be achieved with some cost effective technique in terms of material, in terms of technology, and we will be discussing that in the next lecture. Again, I thank you all to take part in this course, and definitely like I will be waiting for meeting you in the next lecture. Thank you.